Okay, today we are learning about exponential functions. And I just showed you guys on Desmos that an asymptote is a line that you never touch. Is a line that we never touch. Okay, that's what an asymptote is. We get very close. We saw on Desmos how we zoomed into the graph, and from a distance, it looked like it was touching, but when we zoomed in, it wasn't touching at all. Okay, the asymptote for an exponential is always horizontal. So guys, this is the parent function. This is what the parent graph looks like. Nothing was done to it. It wasn't stretched, compressed. It wasn't moved up, down, left, or right. This is the parent function in its natural form. And this is the equation of the parent function here. We're always going to start off every unit with the parent function. Okay? So let's talk about this parent function. Everyone, please draw the asymptote. We just said the asymptote is always horizontal. So draw a horizontal line. This is the line that it gets very close to, but it does not touch. I understand that it looks like it's touching right here, but it's very close to it. It is not actually touching. Okay, the asymptote that we just drew, it crosses the y-axis where? One. This is one right here. It didn't cross there. Wait, this is 1, 2, 3, 4, 5 on the y-axis. So where did this line cross? It crossed at 0. So guys, for asymptote, put y equals 0. The y-intercept, can y'all tell me where the y-intercept is? 1. Yep, 0, 1 right here. So your y-intercept is 0, 1. Let's talk about the x-intercept. We just said that an asymptote is a line that we cannot touch. So will this graph touch the x-axis? No, because there's an asymptote right there. You cannot touch that, okay? So for x-intercept, I'm going to put none. It will not touch this line down here because that's an asymptote. Yes. There is no x-intercept because there's an asymptote on the x-intercept. You cannot touch an asymptote. Okay, the domain. You always read the domain from the left to the right. So draw arrows. Here's an arrow on this part of your graph, and here's an arrow on this part of your graph. It will go forever left, and it'll go forever to the right. So guys, your answer for all of these questions will be all real numbers. So I'm going to put negative infinity to infinity. It will always be that. It will always be negative infinity to infinity. Okay, let's do the range. Range is always the bottom to the top. So guys, the bottom is down here. Where is that? 0. So it'll be 0, and then it goes up, doesn't it? So 0 to infinity. But guys, the 0 needs a parenthesis and not a bracket. It needs to be a parenthesis. If you were to put a bracket, that means you can equal 0. But we cannot equal 0 because there's an asymptote there. So it would be wrong to put a bracket. It must be a parenthesis. Okay? So this is your range, 0 to infinity. Continuing on to transformations, this was not transformed. This is just the parent function. So we can just scribble this out for now. Okay, let's do the next example. This one has been transformed. Okay, let's look at the notes very quickly. I'm going to go to the notes part. Do you guys remember what the letter D will tell you? Yes, how much it went up or down. Please write that down next to the letter D. What does the C tell you? Left and right, thank you. Write that down. What does the letter A in the front tell you? I heard you, thank you. Vertical stretch, if it's greater than 1, or a compress, if it's less than 1. Now, guys, we have this new letter B. This is just your base. That doesn't do anything to your graph. Okay, that is simply your base. So this is kind of a review. We know that the inside, the C value turns it left or right, the D makes it goes up or down, and the A in the very front is a vertical stretch compress. There's really nothing new here. So let's look at an example. Here, guys, I have a +3, so what does that mean? Good, so down here at transformations, put up 3. What does this do right here? This X minus 1. Right 1, good. Write that down. This is the right 1. Now, guys, the 2 is just your base. That doesn't do anything. That's just your base. But what does this negative in the very front do? Yes, it's reflecting. So I'm going to put reflects over the x-axis. So, guys, let me just draw you a picture. The parent function looks like this. When you put a negative in the front, it will hop across the x-axis like a mirror and look like that. It'll face down, okay? That's what happens when you put a negative in the front. That's why this graph is facing down, because it has a negative in its equation, okay? All right, so let's go ahead and answer these questions. What is the y-intercept? It's right here. That's between 2 and 3. So what would you put? Good, 2.5. So I'm going to put 2.5. This is the x-intercept. Where is it? Also at 2.5. So this is 2.50. Reminding you, the asymptote for an exponential is always horizontal. This is what you need to remember. The asymptote for an exponential is always horizontal. So guys, where do you think your asymptote is? This is your asymptote. Everyone draw it. Draw a horizontal line for your asymptote. And where did it cross the y-axis? 3, thank you. So your asymptote is y equals 3. Now, guys, notice, let me highlight something for you. Please pay attention to this. Just like your graph went up 3, your asymptote will match it. Your asymptote is at 3. Those will always match. Okay? Just like our previous example. Did this go up? No, it's just 0. So that's why your asymptote was 0. It will always match. Okay, let's continue. What did we always say the domain will be? All real numbers, because it goes forever to the left and forever to the right. So set notation, we're going to write the domain like this. Negative infinity to infinity with the little fancy curly brackets, x in a bar. That's how you do set notation. X is between negative infinity and positive infinity. Any number you can think of between those two numbers. The range is always read from the bottom to the top. I see so many people starting at the top. In math, you go in order. When you're a little kid and you learn how to count, you go 1, 2, 3, 4. You go from the bottom to the top. You go in order. So in here, in the same way, you need to start at the bottom. What is the bottom pointing at? Good. So what you're going to write first is negative infinity. Where is the top? 3. Do I cross 3? Do I go past 3? No, because there's an asymptote there. It stops at 3. So that is your range. Guys, I see so many people writing 3 to negative infinity. That is wrong. You have to go from the bottom to the top, just like you count, smallest to biggest. Okay? All right, so that's it for this example. Let's go over one more thing. Let's talk about maximum and minimum. So guys, write this on the side of your paper where you have room or at the bottom. So the maximum, or you could just watch, you don't have to write this down. The maximum, let's say the maximum between 1 to -3 and let's say 3. So I'm going to look at my graph between -3 and +3. Here's -3 and here's +3. Do you guys see how the maximum is up here and the minimum is down here? Oh, not right there. The minimum is right here in my interval. Nod if you understand that. Okay, we're looking between -3 and +3. The highest point is here. The lowest point is there. Okay, but guys, what is my maximum? What do you think it is? It cannot be 3 because you can't equal 3. Remember, that's the asymptote. So can you get as close to 3 as you can? 2.9, perfect. Okay, so for the maximum, I'll put 2.9. In fact, I'll put several nines. Get as close to 3 as you can. You can't be 3 because there's an asymptote at 3. Okay? Let's look at the minimum on the same interval. So I'll look between -3 and 3. The minimum's down here. That looks like -1. All right, so that's it for this example. That's how you do maximum and minimum. Okay, let's do one more. Let's do number 6. Okay, let's talk about the transformations real quick. Okay, so I have a negative in the front. What are y'all gonna write? Good, write that down. Reflect over the x-axis. That's why it's facing down now. And this -3 right here? -3. Good, thank you. And it goes up 5. Please write down those transformations. Now, guys, we don't have to look at this equation at all. We don't have to look at the graph at all. Where is my asymptote? 5. It's always this number. So your asymptote is y equals 5. And everyone, please draw the asymptote. It is always horizontal. And it went through the y-axis at the number 5. That is why my equation is y equals 5. Okay? Where is my x-intercept? Think about it before you say it. 3.8 is like right here. 4.8, can y'all get closer? 4.9, thank you. All right, so the y-intercept, I'm gonna put 0, 4.999, really close to 5, but not touching it. Now, you can also write it like this. The y-intercept is close to 5. It doesn't equal 5, it's approximately around 5. You can also write it like that. Not an equals 5, just approximately 5. Okay, x-intercept, where is that? 1, 2, 3, it's between 3 and 4. 3 point, what do y'all want? Sure. I just want a reasonable estimate, okay?
With that one, can you also put it?
Okay, domain, what is always my answer? Yes, it goes forever to the left, and this graph will go all the way to the right. Okay, so we'll put x is between -infinity and infinity. With a little fancy bracket. That's how you write in set notation. Okay, the range. Where's the very bottom? Thank you. -infinity, and where's the top? 5, and we can't equal 5, so put a parenthesis. So guys, that's one way to write it. I want you guys to write another way. I'm gonna say y is it less than 5 or bigger than 5? Less than 5. This whole little red picture that I have, this red graph is below the 5. Okay. All right, so that's pretty much it. Let me just highlight something for you that I want you to remember. This plus 5, you see it in the asymptote and you also see it in the range. Okay, so you really don't need the picture. You can just look off of the equation. Okay, so, let's try a maximum and minimum problem here. Let's say I want to look between -1 and 4. Okay, what is the max between -1 and 4? Wait, it can't be 5. Remember, there's an asymptote at 5. So 4.999. Okay, and what about the minimum on the same interval? So it looks like it's down here at -2. So your minimum would be -2. Okay, next. Now I didn't give you a graph. You have to look at the equation. So guys, where do you think the asymptote is? Yep, the asymptote, I'm just gonna put A, is at -5. And what is the domain always? All real numbers, I'll just put that. And the range? What do you think? There will be a -5. I heard someone say y is less than -5. That's right. Let me draw you a picture so that you can see what this looks like. Can I get y'all's attention? Okay. The parent function always looks like this. However, because you have a negative in the front, it is now facing down. Okay, so it doesn't look like the parent anymore, it's facing down. And then you went down 5. So now you're here. That's what your graph looks like. So she was correct to say that y is below -5. Y is less than -5. You can also put -infinity to -5. Everyone write both ways down. Okay, let's try number 10. What's your asymptote? Yep, 4. What's your domain? Always the same, all real numbers. What is the range? Yep, y is greater than 4. Basically, your range will always be this number. And if your equation is positive, it'll be greater than. If your equation is negative, it'll be a less than. And if you're ever confused, just draw a picture. Okay, let's look at the next one, number 9. What is your base here? For number 9, what's the base? No, this is your base here. E. So those are the bases you'll see. You'll see 2, 10, and E as your bases. So here your base is E. It doesn't do anything. It's just your base. Okay, so guys, it's facing down and it went down 5. So it looks like this. So what's your asymptote? -5. What's your domain? All real numbers. And what's your range? Y is less than -5, or how else could you write it? Yes, -infinity to -5. Perfect. All right, let's try number 10. Did this go up or down? Nope, it didn't go up or down. Guys, this is to the left 5. This is left 5, and this 2 is just your base. So those didn't change anything. So it didn't go up or down. So if it didn't go up or down, what is your asymptote? Yep, it's just 0. It didn't move up or down. Domain is always the same. And your range, what do you think the range will be?
5 to 9. 5 to 9.
So this is your graph here. It didn't move, if it moved left or right, okay, maybe it moved to the left, now it's here. That doesn't affect your range. So what's your range? 0 to infinity, and I heard someone else say y is greater than 0. Perfect, you can write either of those. Oh, sorry, no bracket. Thank you for catching that, no bracket. This is positive, so it's like the parent function, it faces up. It only faces down when you have a negative in the front. Yep. All right, guys, that is the end of our notes. You are doing the practice.